So we will have a 7.4 homework that is due on this coming Wednesday. So anyone here has any homework questions for me with this section 7.4, which is addition and difference of two trigonometric identities, the sine u plus v, sine u minus v, cosine and tangent u minus v, u plus v. Anyone have any questions with this one, the homework? If you do, please email me or ask instructor, okay, or stay back after class if you have any questions with your homework. You guys are all really quiet in this class. So I'm gonna do some announcement here so you guys know what is going on for the next week or two. So one thing I want to point out to you guys is that you guys have no school or no classes on this Thursday, this Friday, and the Monday class, and this is for all North Hennepin College, North Hennepin Community College classes. That means you don't go to school on Thursday, Friday, and this coming Thursday, this coming Friday, and Monday. So so we don't have school next Monday. So I do have some videos that I want you guys to watch, which is about 8.1. So so something that really important here. So where do you watch the videos? I will send you the link via the email. So it will send you some emails, and please do watch that so we don't have school on Monday the 25th. So don't come to the Zoom session in this case. Okay, so this is the first thing I want to point out to you guys. Second thing is we're going to continue with 7.5, which will be multiple angles and product to sum formulas. So as I mentioned last week, that this whole page of formula in 7.5 will be provided to you in test 2. So you do not need to memorize these identities. The only thing is that I won't provide you the types of the formulas. That means I won't tell you this is a double, this is a power reducing, this is half angle, this is sum to product, product to sum formulas. But I can tell you that your formulas in your test 2 will look exactly the same as this. That means I don't jumble up formulas. I just delete all this the formulas name on it. Okay. Some of you asked me that is this name important? Yes, it is. Make sure you know that this is called product to sum. This is sum to product. I will tell you what is a formula here is, so you guys know what it is. So why we call this double angle, why we call this power reducing. So make sure you guys know this. This is very important, especially for test 2 here. So the first formula that you guys have here is called a double angle formula. And the reason why it's called double angle formula, because if you look at your formula here, all your angles is been double. Okay, so that's why it's called double angle formula, is because the formula is been double. Okay, so so if you have an angle and the angle is been double, so make sure you use this formula. This is different from the one that you learned from 7.4, which is the addition and subtraction here. So this double angle formula is actually comes from the addition and subtraction formulas. Okay, so let me show to you how we prove this double angle formula here. So so we start proving the sign here. So we are proving. So make sure you guys pay attention here. So because this is, you will see this in your test 2. So in order for us to prove the double angle formula, we just use sine u plus u. The reason why is because 2u is sine u plus u. So we can written down that as u plus u, which is the same thing as 2u. And we will use the formula you did in 7.4. So if you remember 7.4 formula is say sine u cos v, but our v in this case is u, so sine u times cos u, and then plus cos u times sine v, and our sine v in this case is also u because because both of them are u. And if you look carefully here, these two are like terms. So when you combine them, this will become 2 sine u cos u. So this is the formula for sine 2u, where you use 2 sine u cos u. Okay, so 2 times sine u times cos u. This is the formula for sine u. Now, cosine 2u, we have 3 formulas. 1, 2, and 3. Yes, cosine 2u, we have three types of formulas. And again, how we prove cosine 2u is again very similar as what you guys, I did here for cosine sine u plus u. So this, if you use back the formula for the section 7.4, so this is cos minus sine. So this is cosine u times cosine u, cos. And then you change your sign minus sine. So this is the formula we apply 7.4 here. And when you multiply this is a cosine square u minus sine square u. So you will get the first formula here, which is cosine square u, because cos times cos is cosine, sine times sine is sine square. So you got cosine square minus sine square u. So this is the first formula that we have here. Then we can also do the second and the third formula is by using Pythagorean identity. We can change the sine square u to become 1 minus cosine square u using Pythagorean identity. So if you do that, you will get cosine square u minus 1 minus cosine square u, and this one you distribute it. So when you distribute this one, you will get 2 cosine square u minus 1, because the 2 negative here will become positive. So you will get double 2 of them, 2 cosine square u, and then you got minus 1. So this you will get to the second formula, which is 2 cosine square u minus 1. And then the last one is you take this and you apply Pythagorean identity. So you will get 1 minus sine square u. And then don't forget, we still have a minus sine square u at the back. Okay, so this is a Pythagorean identity. So you get 1 minus sine square u, and then you got a minus sine square. So if you combine these two, you will get 1 minus 2 sine square u. And this is the third formula. So we got 3 formulas for cosine 2u. One is 1 minus 2 sine square u. One is 2 cosine square u minus 1. And the last one is cosine square u minus sine square u. Now, there are 3 formulas here. Which one do you use? It depends on the question, okay? If you want to prove identity, or if you want, this is used a lot when you prove identity or when you try to solve an equation. If your identity consists of sine and cosine function, then I will say use the first one, because the first one have both cosine and sine. If you only have the cosine function, then I will want you to pick the second one. And if you only have sine function, then I will use the third one. So this is how we figure out which one to use for this. There are 3 of them. Okay. So if they have both cosine and sine, use the first one. If you just only have all in terms of cosine, use the second formula. The third one is used if you try to prove everything in terms of sine. Okay, so there are 3 formulas here. So make sure you know which one to use. Okay. Anyone have any questions so far with the double angle formula here? Now we will do tangent to u. So again, tangent to u is u plus u. Okay, so wish you will get this. And where is this tangent, this formula come from? Is again, it comes from 7.4 when we do the addition and subtraction. Can someone tell me what is tangent u plus v is? Anyone? This is 7.4 you learned. What is tangent u plus v?
Tangent u plus tangent v over 1 minus tangent u tan v.
Okay, so it's tangent u plus tangent v. And again, our v here is still u because it's the same. Yep, you're correct, Ming. 1 minus tangent u times tangent v. And again, because it is the v in this case is u, because both of them are u. So this is the tangent u and tangent u. So if you combine them, so this tangent u plus tangent u, you get 2 tangent u. Minus 1, this multiply, you become tangent squared. So you will get the last for the tangent u form 2u formula here is 2 tangent u over 1 minus tangent square u. So this is the for the tangent 2u here. So this is all the double angle formula that we are doing here. The reason why we call double angle is because you got double here. Okay. Anyone have any questions with the double angle formula in this case? Okay. Now, very important. So if you're going to calculus, now this double angle formula can be used not just doubling. So it can be anything that is multiples of 2. So this double angle formula can be used for any even angle formula, even multiply. So what do I mean by that is that if you have a double sine 2u, you get 2 sine u cosine u. But what happens if you have sine 4u? Okay, so that means instead of 2 is 4, that means it's even. Then what happened is that your formula here, your angles will be double. So it'll be 2 sine times sine 2u times cosine 2. So that means that your double angle formula works for any even multipliers. Means that if you have 4 times 2, 4, 6, 8 in this case, then what you need to do is if you have 4, then you'll be doubling here. So can someone tell me what happens when you have 6u? Anyone? Sine 6u? So what happens to your angle? So it will become 2 sine, what is half of 6? U.
3.
So there will be 3u here. So this is how we figure out your even multiplier. So in an even multiplier, I'm going to put n. So 2nu. So sine 2nu is 2 sine nu times cosine nu. So that means that if you have 6 is a 6 times 2 times 3 is 6. So that means your n in this case is 3. So what happens if I want you to find sine 10? Anyone? Nick, Danny, what's sine 10?
Would it be
You go.
2 sine 5u and cosine 5u?
Yep, that is correct. Okay, 2 times sine 5u and cosine 5u. So do not forget that this formula that you see here, we call double angle formula, is also used for even multiplier. Okay, it also applies for cosine. So as you know that cosine 2u, you got 3 of this one, right? So if you put a cosine 2nu, Then this is cosine square nu times sine square nu, and 2 cosine square nu minus 1, and 1 minus 2 sine square nu. So you just change it to nu. So so again, you got 3 of them. So example is, I just give you a quick example here. If you have to find what is cosine of 8u, and anyone know what is half of 8?
4.
4, right? So if you want to use the first formula, then it will be cosine square 4u minus sine square 4u. You guys with me here? And if we want to use the other one, it can be written down as 2 cosine square 4u minus 1. And or if you're going to use the last one, is 1 minus 2 sine square 4u. Okay, so make sure you guys understand that this double angle formula can be used for any even multiplier. Okay, and the last thing is tangent. So yes, tangent is also can be used. So if it's an even 2nu, so 2nu in this case, you just change this all to nu. So if I want you to figure out what is tangent 6u, anyone got an idea what is tangent 6u is? David?
Would that be, would be 2, or would it be
Still
2 tangent 3u?
Mm-hmm.
And then over 1 minus tangent squared 3u?
Yep, that's correct.
Right.
Okay, so make sure you guys know this. This double angle formula can be used for any even multipliers. Okay, this is especially used a lot in your calculus class. If you go to count 1, 2, 3, is a lot of reuse even, and this all comes from this double multiplier, double angle formulas. Questions with this? Anyone? Questions?
Where can we find this in D2L?
It's in my note 7.5.
Okay.
So if you go to 7.5, it's in my notes, chapter 7. It's in chapter 7. So so if you go to D2L, it's in there. So you will get this one. So go to D2L, go to chapter 7. Notes is in there. Okay. Now, so the next thing I'm going to point out here is the next formula here. So as you know that the next formula is called power reducing. What is the meaning of power reducing? Means you reduce your power. So if you look at this formula, this is sine square u, right? This is all square. So a power reducing means you reduce the power from square to power 1. So if you have sine square u, and this is will become 1 minus cosine 2u over 2. So you don't see any square involved here. Same thing with cosine square u is 1 plus cosine u over 2, and tangent square u is 1 minus cosine 2u over by 1 plus cosine 2u. So this is when you have power reducing. Means if you have any squaring, you reduce it into power 1. Okay. If you have a power 4, then you have to do this twice. Okay. What do I mean by that is if you have sine 4u, then you have to do sine square u times sine square u. Because when you multiply this twice, you get 4. And then you will apply this twice. Okay. So you will see this in your examples. Okay. So what happened is that when we use a power reducing, we will power reduce from, if it's a power 2, we have to reduce it to power 1. If you have power 4, you have to reduce it to power 2, and then power 2, you have to reduce it to power 1. So every time when you use a power reducing formula, we want to make it to reduce it into power 1. So it's usually it's even. The power is 2, 4, 6, 8. So we reduce it using that way. Okay. Where is this power reducing formula comes from? This power reducing formula comes from this cosine 2u. So remember that in the double angle formula, we got cosine 2u is cosine square u minus sine square u. Oh, no, sorry. Is the other one. Is the 2 cosine. Let's do the sine first. So the sine one, we're going to use this one. So it's 1 minus 2 sine square u. Okay. And how do we get into this formula here is we try to solve for sine square u. So what do I do is I minus 1 and then I divide with -2 because I need to divide this with -2. So if I rearrange this, so I move the negative upward, so I will get 1 minus cosine 2u over 2. So that's why I got this from using the cosine 2u formulas. Okay. Same thing happens to the cosine square u. When I get this formula, I'm using this formula and I try to solve for cosine square u. So in order for me to prove the other one, it's very easy to prove. The other one is I will take 2 cosine square u minus 1 equals to cosine 2u. And then I want to make cosine square u by itself, so I just solve for it. So I add 1 here, and then I divide it by 2. So that's why you will get the 1 plus cosine 2u over 2. Okay, so it's very straightforward type. And then the last thing is well, how do I get the tangent square u? In order for me to prove the tangent square u is I take the quotient identity. So anyone still remember what is the quotient identity for tangent? What over what? Quotient identity.
Sine over cosine.
So is sine over cosine. So it's sine square u over cosine square u. Okay, and the sine square u came from this. So I just take this whole thing, plug it over here. So it'll be 1 minus cosine 2u over 2. And then for the cosine 2u is this fellow. So I plug it over there. 1 plus cosine 2u over 2. So I just substitute this on the top, sine square u and cosine. And then because they have the same denominator, I can cancel it out. So what I left in this case is 1 minus cosine 2u over by 1 plus cosine 2u. So you notice that that is your tangent to square u is 1 minus cosine 2u and over by 1 plus cosine 2u. So this is how we get the power reducing. We call the formula. Now, this power reducing also work for multiple even multiplier. Remember the even multiplier that I told you just now? So that means that if I have a sine square 2u, then this is no longer 2u, you have to double it. So this will become 4u. Okay, so that means that if you have a sine 2u square 2u, if you want to use a power reducing, you have to 4u it. So the power reducing for this case, it will be sine square nu is equal to 1 minus cosine 2nu over 2. So that means that last time you divide by 2, right? Remember, we have 6, you do 3u, you have 8, you do 4u. Now you double it. So if you have 2, then this is 4. If this is 6, this will be 6 times 2, 12. Okay. Same thing happens to your cosine. So if I have a cosine square nu, this is cosine 2nu plus 1 over 2. So again, you double it. Okay. Same thing with tangent square nu. So this will be 1 minus cosine 2nu over by 1 plus cosine 2nu. So this is the power reducing formulas. Okay. Questions with this one?
Wait, what does the n stand for? Number?
And in this case means it's integers like 0, 1, 2, 3, 4. Okay, so that means that if the questions call you to do 3u, then your n in this case is 3. Okay. So this is because it's multiplied in this case. Okay. That means if n is 3 means you are triple it. Okay, that's the meaning of it. You triple everything. Okay. So that is a power reducing. And the next formula we have is a half angle formula. So what is a half angle formula is you take an angle and you cut it into half. So that's why you look at the formula here, they all are half. So the half angle formula is given us by this formula, plus minus square of 1 minus cosine u, plus minus 1 plus cosine u, or 1 minus cosine u over sine u, and sine u over 1 plus cosine u. So there are two types, two formula in this tangent u over 2. Mostly, which one do we use mostly? Because both of them has sine and cosine for this tangent u2. We will use this formula mostly, this one. Okay, I will check it. So we will use this formula most. We seldom use this formula. Okay, so we do it, but majority we use this formula. The reason why I say we use this formula mostly is compared to the one over there is because your denominator here is only monomial. What's the meaning when I say the denominator is monomial means you only got one term. So when you have a denominator is monomial, you can actually split into 2. Okay, so when your denominator is a monomial, you can split into 2. What do you mean by split into 2 means that the sine u will be split into 2. So you got 1 over sine u minus cosine u over sine u. So you can separate this into 2 pieces. You can only do that if your denominator is a monomial, one term. You cannot split this into 2 terms here. You cannot say this is sine u over 1 plus sine u over cosine u. You cannot do that because the denominator is 2 terms, a binomial. So you cannot split it, but you can split this if you have 1 term. Okay. Where is all these formulas come from? This formula come from your power reducing formula. So remember that your power, let's talk about the sine square u here. So remember that using your power reducing formula, we got this sine square u. So you got the power reducing formula here. So sine square u is equals to 1 minus cosine 2u over 2, right? This is the formula that we use here. Okay. But as you know that this is a half angle. So when you have a half angle means I will divide this by 2. So if your angle is divided by 2, then this also will divide by 2. So as you guys know that whatever you did to the u, you also have to do it to the angle u. You also have to do it to the angle u on the other side of the equation. So when you look at this, the 2 and 2 will cancel out. So I get 1 minus cosine u over 2. Now we need to get rid of the square. So I just square root both sides. And don't forget, when you take a square root, you need a plus and minus. So when you do this, the square and square will cancel out here. So what you have is sine u over 2 is equals to plus minus 1 minus cosine u over 2, which is the same as what we have over here. Okay. Same thing happens with the cosine, because the cosine is this formula. So I just do the same thing. I just divide this by 2. So this will be divided by 2. And then I take the square root on both sides. So what you get in this case is the cosine u over 2 is plus minus square of cosine u, because the 2 will cancel out here, plus 1 over 2. So you get the same formula as this below. Okay. And then tangent is you divide these 2 up. And when you divide these 2 up, you will get 1 minus cosine and 1 plus cosine. And then after that, you do some work here and you will end up with, if you multiply by the conjugate, you will end up with this formula here. So that's the reason why that, so the half angle formulas is using the power reducing formulas to prove it. And same thing happens, you use double angle. So these are all like related to each one another. However, you need to be careful with this one is because you got plus and minuses. You only pick the correct plus or minuses depends on where u over 2 lie. U over 2 lies. In this case, which quadrant? Okay, so this is the meaning of it. So you have to figure out where is the u over 2 lies in this case. That means what quadrant does it goes to? For example, I can show it to you here. They always tell you what quadrant is u is. So so let's say that angle u lies in quadrant 3, for example. So quadrant 3, that means that it is, if you look at your unit circle, quadrant 3 is between pi and 3 pi over 2. So pi is less than u is less than 3 pi over 2. So this is the quadrant lies. So I'm going to show it to you here so it's better. It looks better. So so let's say that u lies in quadrant 3, and quadrant 3 is between pi and 3 pi over 2. So now you need to figure out what is u over 2, what quadrant does it lie, where is it at? Okay, so how do we do that is we just divide this inequality by 2, because when you divide this by 2, then we get u over 2, and then I will divide, if you divide this by 2, then everything has to be divided by 2. So now you will get the u over 2 here. And you will get pi over 2. Can someone tell me what is 3 pi over 2 over 2 is? What's 3 pi over 2 over 2?
3 pi over 4.
This is 3 pi over 4. And what quadrant is it between between pi over 2 and 3 pi over 4? This is in quadrant
2.
Quadrant 2.
Yes, this is in quadrant 2. So that means that in quadrant 2, sign is positive or negative. Anyone? Quadrant 2, sign is positive. Okay, so when you guys do this work, you still, when you have a sign u over 2, you got the plus and minuses here, right? Okay, so if this is in quadrant 2, sine u over 2 will be positive. That means, how about cosine u over 2? If you find out that this is in quadrant 2, cosine u over 2 is plus or minus? It will be on the negative. So that's how you pick which sign you pick, plus or minuses. It depends on what u over 2, what quadrant it belongs to. Okay, and how do we figure out is we divide the angle u by 2 on both sides, and you will figure out what is this quadrant belongs to, and this belongs to quadrant 2. Okay, so this is very important for this case. Okay, so a lot of students mess up with the negative, so be careful with it. And the last two formulas is called product to sum. What is product means? Product means multiplying. So if you look at this, these are all multiplying. So the sine u times sine v and cos u times cos v. To sum, that means multiply to sum. So if you look at the other side, this is all addition and subtraction here. So this formula is used if you want to change a multiple of two sine and cosine to become addition. Okay, so this is called product to sum. This is called sum to product, means if you look at this side, it's all addition and subtraction. And if you look at the other side, it's all multiplication, product, multiply. So, so make sure you guys know that if you look at the questions, if you want to change your multiply to become addition, subtraction, then we use the product to sum. If you want to change the sum to product, means addition, subtraction back to multiplying, then you do this formula. So there are two types. So make sure you guys know which one is which. Okay. So these are all the formulas here. And as I tell you that this is very important, is because when you look at your homework will tell you what formula to use. They will say, use the double angle formula, use the power reducing formula, use the product to sum formula. Yes, if you look at your homework 7.5, they will tell you which, so I'll show it to you here so you guys can see it. They will tell you that what formula to use. Okay, until you prove the identity and solving equations, they don't tell you what formula to use, but majority of them, they will tell you what formula to use. See, solve equations, they don't call you to use any, but majority, they will say use a double angle formula. See that? Use the double angle formulas, use the power reducing formulas, use the power reducing formulas, use the half angle formulas. Do you see that? Use the half angle formulas, and then use the product to sum, use the sum to product. See that? So some of the question in my test will also state that you have to use half angle formulas, you have to use the power reducing formulas, and so on, like your test, like your homework here. So that's the reason why that in your test, I won't provide you the name of these formulas. So you need to know that, but I can tell you really it is exactly this format. Means the first three formulas is double, the next three formulas is power, and then half, and then product to sum to product is fixed. I just, I don't want to change everything around so that you guys get used to this formula page here. So make sure you guys know this formula in this case. Okay, everyone okay here with this? Anyone have any questions for me? Anyone? Now, what we did so far here is they're all like this double angle formula is used when you have double, right, or even, right? So what happens if my double angle formula now is not double, is odd? Okay, so what happens? In other words, what happens when I want you to find what is sine 3u is? Okay, and usually because it's sine, I want it all in terms of sine. So now this is very important. So please pay attention here. So if you have sine 2u, sine 4u, sine 6, sine 8, sine 10u, or even u, you can use this double angle formula which I mentioned earlier on. But what happens if that angle is odd, like 3, 5, 7, 9 u? Can you use this formula? The answer is no. Okay, so for the odd ones, we don't have any formulas for it. Even one, you have it right over here, the double angle formulas. So how do you prove odd one, 3u? So so in this case, in order for us to prove sine 3u in this case is sine 2u plus u. Okay, because 3u is 2u plus u, and you have to use, you learn in 7.4, the sine u plus v. This is your u and this is your v. Yes. So can someone tell me what is sine u plus v here? You learn this in 7.4. Sine u plus v, what's the formula? Adrian?
The original formula?
Yep. Sine u plus v is sine what?
Sine u cosine v
And then?
plus cosine u sine v.
Yep. And then what we do now is just replace all your u and v, become 2u and u. So what you get now, if you replace that to this case. So sine u in this case becomes sine 2u cosine v in this case is cosine u because your v is used, plus cosine u sine 2u. No. Sorry, my bad, wrong. This is sine cosine u, right? Sorry, this is u, and this is v. So this will become cosine 2u and sine u. So that means you get sine 2u, cosine u, cosine 2u, sine u. So this is the part. This is the using the 7.4 additional subtraction formulas. And now we have to use the double angle formula to replace this one and this one because they are double angle. So what is sine 2u? Sine 2u is this fellow. 2 sine u cosine u. And you also have to multiply another cosine u. Now, when you multiply another cosine u, now this is all multiplying. So that multiply of cosine u will give us cosine square u in this case. Okay. Plus this one. Now, if you look at cosine 2u, we got 3 formulas. The first one, the second one, and the third one. Because if you look at here, they're all in terms of sine. So I will use the last one. The reason why I use the last one is because it's all in terms of sine. Okay. So when we want you in sine, we want everything in sine. When we want you in cosine, we want everything in terms of cosine. So in this case, we will use the 1 minus 2 sine squared plus sine. Make sure you guys write this down because it's going to be in the test 2. Okay. Now, as you know that if you look carefully here, everything is in terms of sine u except this. This is not in terms of sine u. So we can change this into sine u using Pythagoras because it's a square. So someone tell me what is the Pythagorean for him. Anyone? Pythagorean for cosine square u? Pythagorean?
1 minus sine 2.
Yep.
Oh, okay.
Yep, you're correct, Nicholas. And this, we will distribute your sine u here. So you will get sine u, because 1 times it, minus 2 sine cube u, because this is square. Then if you square times 1, you get power 3. And then this also, we have to distribute into there, to the first term, the Pythagoras that Nicholas applied. So this you get 2 sine u minus 2 sine cube u, because this is power 3. And then the same thing over here, plus sine u minus 2 sine cube u. And the last thing we do is combine like terms. These 2 terms are like, so you will get 3 sine u. And then these 2 terms are alike because they are sine cube u. So we got minus 4 sine cube. So this is how we prove sine 3u. So
Wait,
sine,
V or U? You put V.
they're all u, sorry. They're all u here. Everything here is u. Everything's u. Okay. So this is how you prove sine 3u, which is 3 sine u minus 4 sine u. And this is how we prove this. So now I want you guys to write this down. I want you to prove that cosine 3u, this is proving, is 4 cosine cube u minus 3 sine, 3 cosine. So the cosine one is actually very similar to this. Again, you just need to change your sign to become cosine, and then you just flip it. This one, the first term, and then the other one. So write this down. I want you guys to prove this. And your proving are very similar to what we did here in sine 3u. Okay, copy it down and I'll put you guys in group. And you guys have to talk about how we do this one. But yes, this is in your test. I think this is also in your notes here, your examples here. Let me see. This is the where was that? There should be a. Oh, it's not in here. Oh, that's not in here. Sorry, my bad. I thought there's in. So okay, prove cosine 3u is 4 cosine 3u minus 3 cosine u. All right, you guys copy it down? Because I'm gonna put you guys in group. Yeah, put you guys through. Okay, go ahead and join the groups. Are you there? Are you? Please join the group. Are you? You guys, let me share the screen so you guys can see how we prove. Please do copy down the sine 3u. That's how you prove sine 3u. Class, you begin have to write things down. So if you haven't write anything down since the beginning of my class, I would suggest you to start to be writing things down. Anyone know how to start with this one? This is in your test too.
Do you have to use the power reducing?
No, we don't use power reducing. It's very similar to what we did in sine 3. See that?
So we split it into cosine 2u plus u. All right.
And then you use 7.4. Make sure you copy down the sine 3u first because it's very similar to it. Right, I'll be back. Anyone? This is in your test too. I'm going to tell you right away, class.
Yeah, I can't figure it out.
Yeah, I'm confused too.
Good. So, what is the first thing you do if you look at this? What do I do on the cosine 3u? I break it down into here, right?
Yeah.
So can you break cosine 3u into something very similar to this one?
Oh, I was not smart. I thought the broken down part was the other side.
No,
my.
we're gonna do on the left side.
Okay, so then it's just, would it just be cos 2u and plus u?
Mm-hmm. And then you use 7.4.
7.4, which would become
Try to do that. Copy down the first. Whoever doesn't copy the sine 3u, please copy down. And then after, this is, as I told you, exactly the same questions in your test. Yep. If you don't want to copy this down, then it's your fault. I'm trying to teach you guys. Start copy things down.
I'm having trouble finding chapter 7.4.
We just did it last week.
No, like in the in D2L.
It's in chapter 7.
Yeah, but I'm looking through it and it skips from. Wait, oh, there it is. I found it. Okay.
You should
So
know
it's
this
gonna
because
be-
just that's your homework due on Wednesday.
Cos 2u. And then cos u. And that's gonna be a minus
Okay,
sine
all right.
2u.
And I'll be back. Yep, that is the starting point of it. Yep,
Okay.
talk among yourself. Anyone know where to start?
A little bit stuck on the two numbers outside the cosines.
Mm-hmm. Where do you start at? Start at.
So what I have so far is a 4 times cosine QU. Cosine
We're gonna
Q.
start from the left-hand side, I mean. We are proving from
Okay.
the left-hand side. Not on the right-hand side, the left-hand side. And it looks very similar to sine 3u here. Do you see that? Have you copied down the sine 3? I don't know who have class, you have to start copy things down here because we won't be doing well. And I told you already, this is going to be in your test. So make sure you do know how to do this because it's very, very important. A lot of people absent in my class today, huh? 1, 2, 3, 4, 5, 6. Anyone, Ming, what you do with
Yes.
cosine 3u? Left hand side. Anyone want to help? Danny? Anders?
I did cosine 3u equals cosine 2u plus u.
Okay, very good, Anders. That's correct. Apply 7.4. What is cosine 2u plus u?
It would be cosine 2u times cosine u.
Cosine 2u times cosine u. Very good. And then?
And then minus sine 2u times sine u.
Yep, that is correct. And now you need to apply 7.5. So if you have 7.5, the whole page of formulas, which is this one, you need to apply it here now. So go ahead. You have to apply it. So this, you have to apply. One of this. And this, you have to apply.
So then for cosine, you could do cosine squared u minus sine squared u.
We don't want to use the first one, Danny. The reason why we don't want to use the first one is because this side is all in terms of cosine. You see that?
Mm-hmm.
So we do not want to use him. So can you tell me which one of these should be used for cosine 2u?
So would it be 2 cosine squared minus 1?
Yep. So this will be using that one. And then you need to multiply that with cosine u. And sine 2u, you got only one choice. The first one, the top one, one choice. And then times with sine u, sine. So try to do this and I'll be back. Yep. So you guys have to start copy things down. I will tell you that this question is coming up in the test exactly the same. I will either come up sine, cosine, or tangent. So you will do this at home for the tangent part. Yep. And I'll be stop sharing here and you guys have to start working on it. Yep. And I'll be back. The attendance here. I think I take you guys really ages.
Wait, so I have a question on that one that you were just going over.
Mm-hmm.
So why couldn't you use that first formula that he suggested on the cosine first half of it?
Which formula? Oh, why
when
cannot
you-
use this the first one?
Yeah.
Because this is all, if you look at the proof side on here, they're all in terms of cosine. See that? They're all cosine here. So if you use the first one, you have to use it. You have to apply Pythagorean identity. So I recommend you to use the second one. The reason why is because the second one is all in terms of cosine.
Oh, okay. That I did it where I just changed the sine 2u to 1 minus cosine.
Yep, you use Pythagoras. Yep, you still get this one. So yes, you're saving time here in this another case, Cameron.
Okay.
Because if you change it, you get the second one. You got it? And I'll be back. See what the rest of the class. How many students? 1, 2. Anyone? Any help? Any questions?
For setting this up, you first turn something into sine 2 sine and in parentheses 2 sine plus sine square.
So what you have in this case is you get cosine 2u plus u, right?
Hold up. Let me peek.
Right.
I'm completely lost right now.
For me, I got cosine 2u, cosine 2 minus sine 2u and sine u. And then I don't know what to do after that.
Yep, that's correct. So
Yeah.
this is when you apply your, again, our proof is on the left-hand side here, not the right-hand side. So this, you use 7.4, you use cos minus sine, because it's a cosine u plus v. So the next thing we're gonna apply here is we're gonna apply this formula. So the cosine 2u and the sine 2u, they are double angles. So we can use this formula. And if you look at cosine 2u, we got 3 formula. The first one, the second one, and the third one. So which one are we going to pick here? It depends on the proving. Since our proving here is all in terms of cosine, so which one should we pick? The first one, the second one, or the third one?
Second one.
We pick the second one. So this, you pick the second one. The reason why we pick the second one is because they're all in terms of cosine. The sine 2u, you only got one choice, which is this fellow. And you have to distribute, then after that, you have to multiply in your cosine u and your sine u in this case. Very similar to this question that we did here. And again, start writing something out in this class. If you're just not writing it out, you will. I can guarantee, I will tell you that your next test, there's no extra credit, there's no anything. So if you flunk it, you flunk it, that's it. Serious here. And this is a very difficult material we're covering right now. Right? Talk among yourself what you guys were doing here. Questions, you guys?
I'm sorry, I got to the part where you did the 2u plus u, but then I just got lost.
What do you get?
I got cos 2 to 2u minus sine 2 2u.
Okay. So what happens is, this is what you do. So this is cosine 2u plus u is cosine 2u times cosine u minus sine 2u times sine u. That's what, Nicholas, you told me, right?
Yeah, cos 2 2u minus sine 2 2u.
Yep. So the cosine 2u, you can use the double angle formula here. And we got 3 of this.
Oh.
And if you look at this, this only have all in terms of cosine. So which formula are we picking here? The first one, the second one, or the third one?
The second one.
Because it's all in terms of cosine, you're correct. So this will be in the second one. And sine 2u, you can only have one choice, which is this fellow. Yeah, this is difficult. It's not easy, I can tell you that. Okay. All right, we're gonna get in together. So I'm gonna start the breakout room. You guys can. All right, so we'll talk about this, how we got sine cosine 3u. So cosine 3u is you use cosine 2u plus u, because that's where you get the 3u from. And using 7.4, this is cosine 2u times cosine u minus sine 2u times sine u. And the 2u is the one that you can use the double angle formula here. And I just mentioned again, there are 3. So because this is all in terms of cosine, so we will be using the middle one. So this will get 2 cosine square u minus 1. Times cosine u, because that is the formula for the addition. And then for the sine 2u, we got only one formula, which is 2 sine u cosine u. So what we do here on the first term is you have to distribute your cosine u in there. So when you distribute, what you guys got?
2 cosine cubed u minus cosine u.
Yep, you will get 2 cosine cubed u minus cosine u. Now, the other part that you see here is this sine u, you don't distribute. The reason why you don't distribute, because this is all only one term. This has 2 terms you distribute. This only have 1 term. So you just multiply in. So when you multiply this in, you will get what? Minus 2.
Oh.
How many sign we have here?
2.
Sine square u, cosine u. But if you look at this whole thing, they all are cosine, 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 except this one is in sine. So we need to change this into cosine because your proving is all cosine here. So what do you do with here? We use what? Pythagorean, right? Can someone tell me what is Pythagorean identity for sine square u?
1 minus cos 2 u.
So what is in front of this is a negative 2 cosine u. Again, because this is all multiplied, I can put that together. So what you need to do here, class, is you have to distribute this negative 2 cosine u into the Pythagorean identity that you get. So what you got when you distribute this into here? Negative.
Negative 2 cosine u times negative or positive 3 cosine.
Positive what?
Positive 3 cosine squared.
No.
Or
so negative times positive 2 cosine u times cosine square u give you cosine what? Cube u. And we have this coming down, so you will get 2 cosine cube u minus cosine u. This is the same idea. I just do this part. Now you combine like terms, what you get when you combine like terms here. So this and this give you how many?
4 cosine cubed u.
And what happens to the cosine square, cosine u?
It just becomes negative 3, I think. Yeah, negative 3 cosine u.
And this is the same as your right hand side. This one.
you always solve from the right left hand side?
Majority of the time. Majority, I can say 80% of the time. So your work, because this is sine, we did sine 3u, right? And we did cosine 3u. Your work in this case is to prove tangent 3u, which is, where was it at? There should be it. Where was that? I forgot what tangent 3u is, but I will find it out. There you go. Tangent 3u is this fellow. So prove, that is your homework here, is prove tangent 3u is 3 tangent u minus tangent cube u over by 1 minus 3 tangent square u. This is, you got to prove this one. Tangent 3u is 3 tangent u minus tangent cube u or by 1 minus 3 tangent square u. So go home and do this on your own. Yep, this one is your homework. So when I come to class on Wednesday, this is the first thing I will check. You know what? Maybe you just need to post it into send, do this. I want you to, in a piece of paper, I want you to give me sine 3u, cosine 3u, and tangent 3u. We already did sine and cosine here, right? We haven't done the 3u, so you got to do that on your own. Do this, and I will ask you guys on the first day on Wednesday. This is very important because it's in your test. Okay. Please do this. Are you guys ready before I move on to the next new page? Okay, so what we're gonna do here next is some examples. Yes, this is tough. I didn't say this section is easy. This section is tough. So we're gonna do the first example here where you use cosine 2x, solve these solutions. So you have to solve cosine 2x minus cosine x equals to 0. And again, you are solving this from 0 to 2 pi. Does anyone know what is the meaning of 0 to 2 pi here in the interval of 0 to 2 pi?
It's not infinity.
It's not infinity. Yep. So it's not infinite solution, only one revolution. Now, a lot of students do this in my test. Oh, cosine 2x minus cosine x. This is cosine x because 2x minus x, 2x minus 1x, right? This one is x, 1x. Is this correct? Is this give me cosine x class? This is wrong.
No.
Okay. If it's a 2 in front, and if they are the same, yes, then this is correct. This will be cosine x. 2 cosine x minus cosine x is cosine x. This is correct. But if this 2 is on the other side, then you cannot do it that way. So what you need to do here is you have to apply your double angle formula here. And if you look at the double angle formula, we got 3 of them for cosine, right? So can someone tell me which one are you picking? The first one, the middle, or the last one, and why?
The middle because it's only cosine.
Yes, because this is in cosine, so you pick the middle one. So the middle one says this is 2 cosine square x minus 1. And then we still have a minus cosine x equals to 0. So this, if you look carefully, is a quadratic type equation. So I'm going to rearrange this so it looks nicer from the high power to low power. 2 cosine square x minus cosine x minus 1 equals to 0. So I want you guys to get back to your group how we factor this. Yes, you need to factor this. This is very similar to your extra credit homework that I think I assigned to you, right? I want you guys to do this question on your own. Copy it down here quick before I put you guys in your groups again. And I want you to solve for x here. You guys copy that down already?
Wait, do we factor it out using the formulas?
Factor.
Or just regular factor?
Regular factor, yes. Yes, regular factor. This is a very similar to 2x squared minus x minus 1. Yeah. Right. I'm gonna put you guys in groups here. You guys have to do the work. Okay, go to your breakout room. Questions, you guys are quiet. You guys know how to factor that one?
After you pass the factory part, do you just solve it and find where it corresponds on the unit circle?
Mm-hmm. Yep.
Then, yeah, I'm basically finished.
How about the rest of the class? Nicholas, did the rest of the class did it? I mean, this group, the rest of the group. Faris, Dosa, Logan, Kate.
I'm on the factoring port.
Okay, Nicholas, can
It's-
you
What?
can you
Factoring?
can you guide them, help them?
I made it an X. And put negative.
Yeah, the 2 from the cosine square x.
What do you mean by the 2?
Yeah, I have a question. So y guy was
What happens to the 2? There's no 2 in there. There's no 2 in there. The 2x here is gone, become this. Is that Ming you're asking for?
no, I'm asking for 2 cosine square x.
Factor it. Do you guys know how to factor 2x squared minus x minus 1? Ming?
Can we take the 2 out and this y guy got 2 times cosine
No.
x minus 1 times. No,
Mm-mm. If you cannot factor this, I will put you back in algebra 1. This is algebra 1 stuff.
yeah, it's been a while.
Mm. Anyone wants to help Ming? Danny, Cameron, Anders?
In the first parenthesis, I had 2 cosine x minus 1.
And yep, continue, Anders.
And then cosine x plus 1.
Mhm. Can you help Ming how you get this? This is factoring, not my class. Algebra 1.
Wouldn't it be 2 cosine x plus 1?
Plus 1
Yeah.
and minus 1?
Mhm.
Which one
Because
is
that's what
right?
I got.
Anders, is this right or the other one right? Plus 1 minus 1 at this. So please talk among yourself. This is factoring. If you doesn't know how to factor this, you should not be in my class. I can tell you that. All right. Help someone else. Ming, ask.
Yes, I did.
Questions? Damon, Jack,
Trying to remember what you do after factoring.
you solve it, make it equal to 0,
Yeah, make it.
and then solve for x.
X plus 1 plus.
Jack, Adrian, Kyle, Yuko.
I'm still trying to figure out. Yeah, I'm still solving.
Do you mind telling me if this is right or not? Okay, I did 2 cosine x equals -1 and divided by 2. Cosine x equals -1 over 2, and then I got 2 pi over 3. And then the other one I
You got
did-
2 answers. You got 2 answers, Yuko.
Yeah, and then
That is wrong. It's -1/2, right?
yep, -1/2.
So it's 2 pi over 3. That is quadrant 2. Yep, that's correct. And then one more.
And then the other one I did cosine x equals
No. You got 2
And-
answers. 2 quadrants.
yeah. So
Not
is it,
finished yet with that.
so is
2
it
pi over-
0 or
No, that's
or-
quadrant 2, right?
is it 2 pi?
What cosine is, what quadrant is cosine is negative?
quadrant 3, right?
You give me
Yeah.
quadrant 2 and quadrant 3. Yep, you got 2 answers in that, just
Okay.
for that case. Yep.
Oh, okay.
Yep, and then the other one yep. All right, the factoring for 2 cosine square x minus cosine x minus 1 is 2 cosine x plus 1 and cosine x minus 1. So this is the correct factor for this. And you have to make them equals to 0. So what you get is cosine x in this case is -1/2. And cosine x in this case is 1. So you have to make them equals to 0 and solve for x. And then you move the cos over. So this will become arc cosine of it. So what is the arc cosine of -1/2? What quadrant is supposed to belong to for when cosine is negative? What quadrant?
That's 3 and 2 and 3.
Yep, you got 2 answers. That means one is in quadrant 2 and one is quadrant 3. So what gives us -1/2 for cosine?
4 pi
Pi over
over
3 and 4 pi over 3.
I'm sorry, I heard 4 pi over 3. That is quadrant 3. And what else? Anyone?
2 pi over 3.
Okay, so this is correct. So this is for quadrant, this is for just this one. So now we do the same thing for this one. So you move the cosine over, become arc cosine here. So can someone tell me what is the arc cosine of 1?
Pi.
This is pi. And this is your answer in this case. Question 2, this is how we do question 2 is you square this. So do you guys know how to square sine 2x plus cosine 2x? So you just FOIL it. So go ahead and FOIL this one out. What is sine 2x cosine 2x times sine 2x cosine 2x? You guys know the FOIL, right? FOIL this one out. So this will give me what when you FOIL? Adrian, what happens when you FOIL this?
You get sine squared 2x
Plus
cosine 2x sine 2x.
And
then you get
same thing.
Yeah, then you get the same thing too.
That means
after
it's
that.
2 of them.
Yeah.
And then what's the last one?
The last one. Cosine squared 2x.
Yep. And this is all equals to 1. Now, As you know that this and this is a Pythagorean identity. Guys, remember what happens when you add sine square u plus cosine square u, you get what? What's sine square plus cosine square u?
1.
You get 1. So this actually will give us 1 using Pythagorean. And so we have this 2 cosine x sine 2, 2 cosine 2x sine 2x. So if you look at your formula, the 2 cosine 2x sine 2x is actually this. You got the 2 cosine u sine sine u cosine u. But what is this will be is not sine 2u. This is sine what?
4u.
4u or 4x in this case. Okay. So because your u in this case is 2, so that means you're doubling it, so it becomes 4. And then this 2 will become 1 using Pythagorean. So now we will subtract 1 here. So we will get sine 4x equals to 0. So this has how many answers? Because you got 4x. So last time, remember, you only got x. You got 2 answers here. So this one means you have to multiply this by 4. Okay. So when you have 4x means you will get, if you have 1 answer, you get 4. You got 2 answers, you get 8. So we move the sign over there. So can someone tell me what is the arcsine of 0? Arcsine of 0 is
Pi.
pi.
Oh no, wait. Would it be 0?
Sine is x or y?
Sine is y.
Y. So which one of these give us y equals to 0?
Pi and 0.
0 and pi, yep. Now, because you got 2 answers and because you got 4x, so you had to give me 8 of this. So can someone tell me, besides 0 and pi, what else do we have here?
2 pi.
2 pi. You need 8 of them, followed by what? 3 pi.
Pi, 4 pi,
All the way to what?
7 pi.
Yep, all the way to 7 pi. And the reason why we need 8 is because of this 4x. You have to have 8 answer. So what you need to do here is you have to divide everything here by 4. So this is your answer. 0 divided by 4 is 0. Pi divided by 4 is pi 4. 2 pi over 4 is pi half. 3 pi over 4. 4 over 4 is 1 pi. And then 5 pi over 4. 3 pi over 2. And the last one is 7 pi over 4. So this is your 8 answers. Yes, you get 8 answers due to this 4x here.
So 4x means that there's 4 revolutions?
Yes, you're correct.
Okay.
So if you got 4x means you go through 4 revolutions. If you got 2x means you only go through 2 revolutions. Yep.
Is that 3 pi, 4 pi, 5 pi over 4?
Yep. And then 3 pi over 2 and 7 pi over 4. So make everything over 4. And if you can reduce the fraction, reduce the fraction. Like 2 and 4 can reduce to half. 6 over 4, 3/2. So that is how we do question number 2 in this case. So we're going to end today's Zoom class. So you do have a homework for me, which is you have to do the tangent. Remember the tangent one that I call you guys to do? You have to do the tangent one. I would recommend you guys to start really do some work here on your own here because this section is really difficult. So this is your homework on top of 7.4 homework that is due on Wednesday online. This is your homework here that you have to do for me. So I want you to prove this. The reason why is if you don't do it, I will guarantee you your next test, you will not gonna be do well in the next test. Okay, so this is your homework. Make sure you do it for me. So I'm gonna stop sharing here. I also recommend you to print out my notes because those are really important. So you ask me where is my notes, go to D2L and you can check the notes in there. They are all the note. You can also go to instructor notes. Every notes I'll fill out. So I would recommend you guys to either print out the instructor notes or print out the blank notes so you can write your own. My suggestion is do the blank one because I want you to write it. If you print out my notes, you are lazy, you don't write it. In the test, you have to write it down. So make sure that I would highly recommend you to print out my notes here. We're gonna end today's Zoom here. So anyone have any questions for me? If you do, stay. If you don't, you can leave my Zoom class here.